Good afternoon.
Hello.
Hello.
People can have freedom of speech without having to worry about getting people for saying something.
All right, it's 12:30. We'll get started. So we're looking here at test 4. Now, as you all know, test 3 has been graded, and everything's. If you're asking about the abbreviations in the feedback, go back to look at the email I sent for the first test, I think, and that will give you an idea of the what the abbreviations mean. Okay, but I have done it before. I've sent you abbreviations. Okay, sorry, was that a question? Anybody have any questions? Okay. So what we're going to do is we're going to go through test 4. We're going to start with test 4, and we're looking now at types of dienes and Diels-Alder reactions specifically. And with the Diels-Alder reaction, we're looking at what's called an electrocyclic reaction. Let me get rid of this stuff here. And it's similar to aromaticity. It involves 6 pi electrons like benzene, all moving in a cyclic electronic array. So first of all, let's look at the kinds of dienes that we're talking about. Di means 2, ene means double bond. So we're talking about compounds that have 2 double bonds. Deanne, do you have a question? Okay. We have conjugated, which indicates that there is a progression. We have double bond, single bond, double bond, so it alternates. Cumulated means that they're both coming off the same carbon atom. Those are fairly unstable kinds of creatures. And then you've got the isolated ones where there's more than one carbon atom between or more than one bond between the 2 double bonds. And you can see an example of an isolated one there. We're not talking about the isolated or the cumulated here. We're talking about specifically the conjugated ones. They're the ones we're mainly going to be focusing on here. Now, the Diels-Alder reactions only involve the conjugated dienes, So the reaction itself consists of two parts, a diene, a conjugated diene, and a double bond compound usually has one double bond in it. But I mean, it can have more, but generally one double bond, and we call that B-dienophile. Now, dienophile means, if phile means like or loving, so diene loving, so it's the compound that's going to react with the diene. That's how you've got to express it. And when it reacts in such a way that the stereochemistry ends up being preserved. So if we have a cis double bond, it will form a cis ring. If we have a trans double bond, it forms a trans ring. So what I'm going to do, I'm not very artistic here, but I'm going to show you a representation of what's going on in this reaction that sort of explains why the stereochemistry ends up the way it does. So what I'm going to do is I'm going to do the cis one here. I'm kind of going to try and draw this diene in a 3D fashion, sort of laying down, if you will. And then we've got the dienophile here, cis dienophile. And just a reminder about how to tell if a double bond is cis or trans. You can tell just by looking at the line structure. The cis looks like a cup and the trans looks like a zigzag. So you can see that this is the cis one that we're talking about. It means that the bonds are on both the same sides as double bonds, and there's a double bond, and they've got hydrogens here that we don't draw in due to the line structure. But the way the arrows go looks like this. So it's electrocyclic. It doesn't actually matter which way you put the arrows, whether you put them to the left or the right, or clockwise or counterclockwise. Now I'm going to show you what this looks like in a sort of transition state. So this is as the reaction's occurring. Initially. Now just for kicks, I'm going to put in the hydrogens as well here. Okay, so there's your H's there. So you can see that we've got two bonds forming here where the dashed lines are, and then we've got a double bond forming down here as well at the same time in the back. And then you can see that once this is completed and it flattens itself out, because it was concerted, it all happened at the same time, the stereochemistry ends up being, actually I won't do that, I'll just do it this way. The stereochemistry ends up being preserved. All right, does anybody have any questions?
Yeah, so where does your arrow end? Like, are you taking, on the first image, are you taking the double bond to the carbon? Or are you?
No, actually, Mariam, I could do that, and it wouldn't be wrong to do that. But what I've actually done is I've drawn the arrow into the space between this C, where I've got the cursor, and this C to form that new bond.
Okay, I see.
And I'm doing the same with the other arrow down here.
I see.
Okay, so they're going into the space. Remember, we're moving electrons around, right?
Right.
Okay. Does anybody have any other questions about this so far? So you can see we can do something similar with the trans one, and we're going to end up getting preservation of the stereochemistry with trans as well by the same argument. I guess I'll show you that. So it's kind of flat. Is the way I'm trying to draw this. Again, it doesn't matter which direction, clockwise or counterclockwise, we draw the arrows. And that's how it looks for the trans. So this is cis. And this is trans. All right. Does anybody have any questions there about the way this goes? Second, one thing I didn't do. Need to put the double bonds in here as well, the back. Okay. All right, so that's the first example. Those aren't too bad. I'll show you some examples of those from old tests in a little bit, and we'll do those examples. But before we do that, I want to go through the other kind of more complicated deals all the problem that a lot of people don't like very much. And that's the one with the rings already attached. So the diene now is going to be part of, the diene now is going to be inside a ring. Now, if we do that, we end up with what's called a fused ring compound. So you can see that if we do the same process with the arrows, we end up with something like this, and then it needs to be drawn as a 3D diagram so that we can see where all the carbons are heading. Now, the same rules apply here as applied previously with regard to the stereochemistry of the diene file, the double bond compound. If it's cis, you end up with a cis product here, and if it's trans, you end up with a trans product. Now, this double bond is part of a ring, so it has to be cis because it's set up like a cup. And then it can react, and then we need to be able to draw it as a 3D structure. And that's where people really hate. That's what they really hate, is taking the 2D diagram and converting it into a 3D diagram. It looks like this. I can already hear people being scared by this already. I can hear the teeth chattering and heart beating and people sweating already. All right.
Well, I do have a question from the videos, and I'm sure you're going to get to it, but I'm going to preempt that for you. So with the endo and exo, I was getting a little confused. And just to confirm, when you say it's pointing away from the double bond or towards the double bond, you mean the cyclic unit, not the constituents, correct? The cyclic unit. Okay, perfect. That was my, okay, thank you.
Yeah, so there are two possible ways that we can get interaction of the double bond compound with the diene. So I'm going to try and draw them here, both of them, and you'll see why we end up getting these two exo and endo forms. Generally speaking, the exo is the endo is usually favored, and there's a reason for that, but I'll get to that in a minute. So I'm going to lay the diene here kind of flat in a 3D kind of setup. My video actually goes into this a little bit better because I use that website and that to kind of help out.
Could I just ask one clarifying question?
Yeah.
It might have already been asked, but I'm not sure. On this, where it can be exo or endo.
Yeah.
It can be exo or endo, whether the deionophile is cis or trans.
That's a good question. It's a good question. You know what? I think that's really a good question, Julie. I think it only really applies to cis, because I don't think you could easily tell otherwise. So yeah, so I think this endo and exo argument really only applies to cis.
Okay.
Because as you can see, the reason that we end up getting two possible forms is because there's two possible ways that we can join the diene with the dienophile. It's always to the ends of the double bonds. But you can see how we lay it flat, and one will give the endo form and one will give the exo form. This one will give the exo, and this one will give the endo. Now, the reason endo is favored is because sometimes there's other things like double bonds that can help with the interaction. So often that's why the endo will tend to be favored. But you don't really need to worry about that. And on a test, I actually don't care if you draw the exo or the endo if it happens to be an available option. It may or may not be, just as Julie pointed out, because if it's trans, you wouldn't really be able to tell.
You couldn't really have a trans ring anyway, could you?
Not a trans ring, but you could have a trans double bond. Yeah, it would be very difficult to have a trans ring because trans rings would be incredibly strained because they had to be flat at the double bond. So yeah, I don't think it's a problem we're really going to have to ever deal with. But when you said that trans, I wasn't talking about rings. I was really just talking about trans compounds, Julie.
But they don't have the endo and exo, do they?
No, not really, because you can't really say one way or the other. You've got one pointing up, one pointing down. You could still, it could be asymmetric, and you could end up with two different compounds, but they wouldn't be called exo or endo per se, because you couldn't really tell.
Okay.
Is that fair enough?
Yeah, thank you.
All right. Does anybody have any questions? All right, let's talk about this hard part here. Well, we'll look at if you look at the diagram I have here, you can see the way that the arrows go and what's joining together. So it's the ends of the diene with the carbons of the dienophile, which are here. And we end up getting this kind of arrangement. These two bonds here I'm pointing to with the cursor, they're the new bonds that were formed by the two arrows here and here. And then you've got a double bond at the back formed by the third arrow. So let me talk about how to do this part of it. So what you can do is for the part where it formed, and I'm going to go ahead and put the C's in here. And these C's that I'm putting in here are the pink C's that are in the diagram over here. So you can see that we can always set this up like kind of like a tent. And that's that six-membered ring part. So which part is that? It's this part right here that I'm circling with the cursor. Does anybody have any questions about this so far? I haven't finished anywhere near this yet. Now, if you look at the middle C's, it's joined by a bridge, and I'm going to push that bridge right up. So that is this here. Now, the reason I've drawn it this way is because I want everything to be as far apart from everything as I can, so that we have fewer interactions. Now, I'll do the exo here, and the exo is going to have that ring pointing upwards. Now, it's probably not the best. Let's try that again. Okay, and that's that six-membered ring right here. And if it's pointing up, it's exo. If it was pointing down, it would be endo. So that's how we draw it. Does anybody have any questions? All right, let's do a poll. I want to see where you're at with it. So what we're talking about here is this whole dual ring situation. Just want to see where people are at. I'll give you 5 more seconds. 4, 3, 2, 1, 0. Okay. Okay. All right. So that's where we're at. Now I kind of expected that. Okay. So what I'm going to do is I'm going to do a bunch of examples now of both kinds here, based on what we're seeing on the old tests. Okay. So let's go do it. Let's look at spring 2017. Now, when you're going through the test, what you'll notice is that you'll have somewhere in question 1, you'll have an example of two deals all the reactions. One is like the first one where it's a cis or trans, but it's not like it's not like the double bond, the diene compound is part of a ring, right? So there'll be one, and then there's one where the diene is inside a ring. So let's look and see if we can classify those two. We can find them here in this test. It'll always be that way. Let's see. Oh my gosh, don't know what happened to that. This is a very old version of Word, so I think that's the problem. Okay, so you can see the two situations that we're talking about. Look at the top one. Look at where the diene is. You'll see that that's inside a ring, right? And if you look at the other one, the diene is not inside a ring, it's outside a ring. So you can see how those two are different. Does anybody have any questions so far about saying the difference between those or telling the difference? Okay. Let's look at we're going to look at the bottom one first because that one's a bit easier. So the way it works, and I don't know how many of you are familiar with Pac-Man. I don't know. Is there anybody who knows what I'm talking about?
Yes.
Oh, okay. No, okay. There are some. Okay, I think we have some Pac-Man fans or some Ms. Pac-Man fans in the audience. I don't know though, but we'll see. But the way you've got to set it up is, I like to set it up so I have the double bond compound here coming to sort of eat the diene compound coming to eat the dienophyre, sort of like Pac-Man. I don't know. I'd have to show you, but it's kind of like that. So the diene is going to come along and eat the dienophyre, but it needs to be set up that way. So it has to be set. I'll put it up. Let me show you my Pac-Man setup here. I'll put it up the top here. So there's your diene and there's your dienophyre. So it has to be set up that way. Pac-Man mode. Okay. I would run a poll, but it's not really worth it. Okay, let's see. Where's my questions? Here they are. Whoops. No. Here I've got to find my word here. Where are you? Here it is. Okay. So Pac-Man mode, what does that mean here? So what I'm doing is I'm going to rearrange this. I'm going to have to twist things around. Whoops. Yeah, so I get it in the same mode. All right, so you can sort of see what I've done, right? Does anybody have any questions? And then we can see how this works. Put in the thing. Okay, and the answer is going to look like this. So it'll be double bond here. And then this will have a certain stereochemistry, and this is going to be cis because this double bond is cis. So it can be either both up or both down, it doesn't matter which. And attached to those, we've got the C double bond O's. So that would be an appropriate answer for that. Does anybody have any questions? All right, tell me how you feel about this question. Okay, 5, 4, 3, 2, 1. Okay. All right. At least we don't have any. At least we have somebody. At least we don't have to. I have no idea what's going on. That's good. But we still have some halfway understanding. Is there any questions anybody could ask you and help out?
Could you, I don't know if it would help me, but could you number the carbon for that second part of the ring that's fused to the first one?
I'll try and draw it a little bit better too, Marion.
Okay, thank you.
Okay. Let me see. I'll see if I can get a little bit fancy here. Okay, it might not be the best choice of color, but we'll see. All right, do you see the two C's I just put in, Miriam?
Yeah.
Yeah, okay, you can see where they are in the product, right?
Yes.
Okay. Let's do a different color. We'll do pink. I'm just choosing the worst possible colors here. That's okay. This one and this one, this one and this one.
Okay. Yeah, that definitely helped. Thank you.
All right, I'm going to do one more here just to be super, super clear. And let's see, we'll do him in cyan or something like that. There we go. So that's the end carbons here, the blue ones, which go in here and here. Right, so that might be helpful. Does anybody have any questions? Well, let's see if that helped anybody. Did that help anybody? Do you feel any better about it? Okay, 5, 4, 3, 2, 1. Some people don't like to vote. All right. There you go. Yeah, so yeah, see, Miriam, that was good. See, because you asked that question, you got some more people to understand it. Do you see what happens? It's not just for you. It's not all about you, Miriam. Do you see that? Yeah.
Yep.
So yeah, you see, you should feel pretty good about that. All right, any questions? All right, let's go take a look at the other one. This one's going to be a little bit nastier, I will admit. But let's get the 2D done first. I have to change the color back here to black. Back in black. All right. So I'm going to set this up Pac-Man style. Let's focus first of all on getting the 2D diagram. And what I will do is I will kind of take a similar approach to what I just did, but I will use, let's use this color here. And I will just put in the C's here and here. So I'm focusing on the C's that are at the ends. Now I'm going to draw the arrows here. Oh, I'm not liking this too much, but all right, so this will be the 2D diagram. I warn you right now, you're not going to like it. All right, so that's a trans double bond. That's why we end up with the trans product. Oops. Didn't mean to do that. There we go. Let's put the C's in again. All right, so you can see what I've done is I've kind of lengthened those bonds to make it work a bit. But that's the 2D diagram right there. Does anybody have any questions so far?
On your first diagram, I'm kind of confused on where the arrows are going. Are they just going into empty space, or are they going into?
Yeah, they're going into the empty space between the purple C's here. So
Okay.
was that you, Keisha, asking that?
Yes.
Yeah,
yes,
do you see this C here and this C here?
Yes.
So, and that's a new bond that I'm pointing at right now with the cursor. See that?
Yes.
It's the result of that arrow. Likewise, this is a new bond down here as well, which is the result of this arrow.
Okay.
All right, you with me?
Yes.
Okay.
Thank you.
All right, does anybody have any other questions so far about the 2D diagram? Okay. Gingerly, I'll ask again how people are feeling about this one so far, just up to the 2D. Just up to the 2D. 5, 4, 3, 2, 1. It thinks I'm playing music. I wasn't. I guess I'm just a better singer than I thought. So there you go. So that's good so far. Does anybody have any questions though? All right. Now I'm going to show you what the 3D diagram looks like, okay? Now what we're focusing on here, and I'm going to do this again in a different color, but I won't do purple. I'll do, say, this funky green olive color here. So we're going to focus on this ring right here. That's the new ring that we kind of created. That 6-membered ring. Oops, I didn't mean to do that. I want to curve this more, not make it look so much like a new bond or anything. There we go. So that's a 6-membered ring right there that we're talking about. Okay. So let's let's look at what that looks like in 3 dimensions. So this is that kind of book shape. Cool. Suppose I should use the same color, but anyway, that's the green. That's the green area right there. All right. Let's put some colors in just for kicks. Oops. I'll put the double bond in too. Okay. And then the purple. Okay. Does anybody have any questions so far? All right, let's talk about what's connected to each one now. So let's do the bridge first. And the bridge is going to be connected to the 2 things with the NO2 on it. This is the bridge. And the NO2 is going to be trans. So one's going to be pointing this way. And the other one's going to be pointing this way. All right. Any questions?
Yeah, that just really threw me for a loop.
We're only doing this part so far.
But you're saying that the.
Oh, hang on. Sorry. No, that should have thrown you for a loop because I did the wrong thing, didn't I? I was looking at the. I didn't do that. All right. Let's see if I can reverse this a bit. I don't know how far I can take this back before. Anyway, as far as I can. Sorry, Julie, you're right.
Well, that's a good thing,
You are.
because if you were right, I was really lost.
Oh no. Let's try this again. Let's look at the NO2s. You're right. Hang on. Let's just do the NO2s first, because if that's what I'm doing. Yeah, that's okay. That's okay. Yeah, we can still do this. Sorry. Okay. So here we've got one NO2 up and one NO2 down. Do you feel better about that?
Definitely.
Okay, good. Anybody got any questions? All right, now let's focus on the bridge. The bridge is this area here, which I kind of mixed up. Because sometimes you can do it the other way too. That's the thing. So there's the bridge, which is this area right here that I'm circling with my cursor right now, just outlining. And attached to that, you'll have a ring, and that ring has got to be pointing left or right. It doesn't matter which, but it has to be pointing left or right. It can't be pointing straight up because that's not what the bond angles are like. Let's do this a little bit more angled. And let's see, all right. So attached to that, we will have a ring. And I haven't done a very good job of that, so I've kind of tried to squeeze it in. All right, let me see if I can fix that a bit. Too far. All right, let me see. I'm going to fix it a little bit so I can do this a little bit more. Okay, I'm just going to point this in another direction. Excuse me. Okay. So now this one does have to be flat because that's a double bond right there. Let's see. There we go. And that would be the final answer there. So remember that around double bonds, everything's flat. Everything's in the same plane. Whereas if it's a single bond, then you've got things pointing up and down on the single bond. Okay, questions?
So are you saying that it matters how we draw the ring that's attached to the double bond? Like,
yes, it matters. It needs.
so if it wouldn't appear flat, how would it look like?
Well, it would look more like this one up here. Do you see how that's pointing to the right, Miriam?
Right.
But it could be pointing to the left, but it can't be pointing straight up because that would mean it was planar. So it can't go like this. That might be a better way of putting it. I'm gonna draw it in, but I'm gonna erase it. Okay.
Okay.
I'll show you what flat would look like. Flat or planar would look like this now. That would be planar, straight up.
I see.
Right. So it can't be like that on that one, but it has to be like that on the one that has a double bond. So double bond one can't be pointing up or down. It has to be in the same plane.
Kind of need a perspective course to do this.
I kind of figured, Julie, you would not be a real fan of this.
No, actually, I'm an artist, so I have no problem with it.
Oh, okay.
But you kind of need a perspective course to understand it.
I've always wondered if I needed more perspective, Julie. All right. Any questions? Yeah, not the first time in my life I've been accused of needing more perspective. All right. Let's do a little poll here. We'll see how people are going with it. I'm not really hopeful about this one, but that's okay. All right. Okay. How are you feeling about this problem?
Well, understand and know what should happen. Yes. Need lots of practice to make it happen. Still needs.
I just want to get a general idea about your feeling, really. What's your feeling? It's actually better than I thought it would be. It's not too bad. All right. Any questions? All right, let's do some. We'll do some more examples here. Keep going. Keep going. Keep cruising. Okay, let's get rid of that. Go back to the test and we'll do the next one. Whee! All right, so let's see. So this, you'll notice. Okay, so what do you think? Is this going to be one that needs a 3D structure, or do you think it's one that needs a 2D structure? So what you do is you look at the diene, and you can see the diene is part of a ring. So this one's going to need to be 3D. Here's the other one here. This one is the one that is going to be the 2D structure. We'll do this one first, just for kicks. So remember, set this one up like Pac-Man. Remember what Pac-Man looks like.
I want to make sure I heard you right. The diene is the one that decides whether it's going to be 2D or 3D.
Yeah, that's right. If the diene is inside the ring, it's going to be 3D. If it ain't, it's going to be 2D. Okay. So let's set this up in that way. Now, there's a whole lot of other theory that I haven't talked about with regard to this, and the groups attached and all of that, that's in the video. So I'm going to leave that to you to watch. I don't really want to go through it in class. I'd rather focus on just doing examples because I think that's going to be more useful to people in going through the theory behind this. Do I like that? Sort of. Let's see. Let's try that again. I'll put it over here a bit more. Okay. Does anybody have any questions so far? I could have put it upside down, by the way, but it wouldn't have made a difference. So let's look at the arrows. And the product looks like this. All right, there's your answer right there. You'll notice that the trans double bond comes out as a trans ring, and you can see how everything else joins together. And I will just go ahead and just put in the C's. I want to use a separate color this time. These are the C's that are joining together. So does anybody have any questions so far? All right, let's see. How do you all feel about this one?
Not happy.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. No. So any questions? So a fair number of people still kind of in the in-between stage here. Any questions? Let me put the C's on here, and then if that helps. See. So those are the black C's that I have in the diagram. Anybody have any questions? Okay, let's go take a look at the 3D one. Okay, so let's set this up Pac-Man style. Oops. That's probably not a very good color. Come up very well, does it? Okay, let's do Okay. So looking at a 2D representation of this,
And you could reverse the hashes and the wedges.
yes,
Or-
yes,
Okay,
that's right.
I just wanted to make sure.
Yeah. It has just, they just have to be in the same orientation, really. Okay. All right, let's see. How do you feel about the 2D diagram? How do you feel about the 2D diagram? 5, 4, 3, 2, 1. Okay, that's where we're at. Anybody got any questions? Anybody got any questions?
There is a double bond on that ring, right?
Oh, hang on, where are we? Right here, right?
Yes.
Yeah, yes, there is. Right here. Yes, you're completely correct. There is. Okay. Now let's put together, and I'll do the same thing as I did before. I'll use the ugly green color. I shouldn't call it ugly. It's probably clover. Okay. I'll do it in clover. Okay, so this is the new ring that we just formed. And this is the one that kind of looks like a book. Okay. Any questions? You need to mute. You need to mute, Julie. Sorry, I'm gonna mute Julie here. If I can find Julie. There she is. Okay. Okay. And we'll put in those C's as well. Okay. Any questions so far? Let's look at the bridge. The bridge is to this oxygen here between these two C's. That's that one there. That's the bridge. And then we got to talk about what's going on down here. Now, this is a single bond. So one of those situations is sticking up. That's the 5-membered ring. And what's sticking down is the aldehyde groups. Okay, any questions?
Yeah, I have a question.
Mm-hmm.
I understand why the C's attached to the double bondos are facing in one direction because it's cis.
Mm-hmm.
Could you tell me again why the other piece is the opposite?
Because it's on the other side of a double bond. It's all flat initially.
So it's
Yeah.
always gonna go, whatever's on the other side of the double bond's always gonna go in the other direction.
Yes, but it doesn't matter if they're both sticking up or both sticking down. That's the whole endo and exo thing, sort of. This one's exo. I've drawn here. If you look at the ring orientation.
But if it was endo and it was sticking down, then the other pieces would be sticking up.
Correct.
Okay.
Now I'm still not done yet. We've got something attached to the double bond, and that's this 5-member ring here, and that has to be flat. Yeah, so that's supposed to be kind of drawn flat there. All right, does anybody have any questions? Anybody have any questions? All right, how do you feel about this one? How do you feel about this one?
So for the exam, are you going to be extremely critical of how flat the piece is, or is there?
Well, if you really want me to know it's flat, you can always write flat beside it.
Okay, thank you.
Sometimes people do that. But I'll give you the benefit of the doubt. It's usually pretty obvious when people know what they're doing when they're don't know what they're doing. Okay, and pole here. There we go. And it's not too bad, considering where we're at. It's not too bad. All right. Does anybody have any questions that could help you? Okay. Let's do another one. Spring 2019. Okay. All right. So this one here, that's the 2D, because you got the die in there that's outside of the ring, and I've got the whirling pinwheel of death here, which I'm not liking. But, I don't know if anybody's familiar. This is Word 2008. That's how old this computer is. It's a Mac though, so it's still going. All right. I have a Mac laptop that I've had since 2013. It's still cruising. I can't say there's too many people who have PCs that old that reckon they're still operating like the day they bought it. I don't know. I'm kind of nervous about buying a new Mac though. I don't know what they're going to be like now. Anybody buy one recently?
Yeah, almost all the new ones have the touch bar right at the very top of the keyboard.
You like it?
Kind of. My old 2012 MacBook finally died on me, so had to upgrade.
Like the USB-C, single USB-C port, that bothers me a bit. Okay. All right, so C. Okay. Okay, so that's an acceptable answer there. And of course you can reverse those two. One could be up and one could be down. All right. Does anybody have any questions about it? All right, let's see how you feel about it.
I have a question. Do the C double bond O's both have to point up?
No.
Okay.
Okay, how do you feel about that one? 5, 4, 3, 2, 1. Okay. So yeah, things are going better now. It's good. Any questions? Yeah, so I hit the pinwheel of death here. I'm going to have to re-upload this, unfortunately. Re-download it, isn't it? Yeah, I've got to find it and force quit it, unfortunately. Yes. So that sometimes that version of Word is not very helpful. Oh no. Okay. Sorry. I'm going to stop this time. There we go. So there's your other one, and you can see that one. You see that one has the diene as part of the ring system there. Oops. Didn't mean to do that. It's unfortunate. Here we go. Why don't you all try it yourselves, see if you can come up with the answer on your own. This is going to be one that requires a 3D, so do the 2D first and see where you end up. I'll give you a couple of minutes. See if you can come up with an answer. This will give you an idea of how you're doing.
You had to do the 7-sided because you're evil.
Well, evil. I don't know. It actually doesn't look that bad when you draw it out in 3D. Okay, I'm going to start doing the 2D now, and you can still continue what you're doing. Okay. Any questions so far? That's about the 2D diagram. Let's do Clover again for the okay. This is the C's. And now I'm going to do the book part, which is the green part. Awful. Okay. So there's the green part there. Now let's do the bridge first. Do that in black. Now the bridge, actually let's put double. Oops. Let's go back and do that. Okay, let's look at the bridge. The bridge looks like this. That's the bridge. And then you've got the 6-membered ring that's going to be pointing up or down. And then you've got this 4-membered ring, which is going to be flat because it's on the double bond. I think that's it. Does anybody have any questions? Okay, let's see how you feel about that one. How do you feel about that one?
I mean, I understand, but my drawing looks pretty ugly.
Oh, that's okay. That's what I wasn't asking. I wasn't asking if your drawing was ugly. If that were the case, it'd be a completely different poll. There we go. It's pretty good. That's pretty good for that one. Okay. Let's do the last one here. Spring 2019. Okay, so that one there, that one is your 2D diagram. I'm not going to worry about that one for now. Well, I'll just show you the answer. I won't do the whole thing, but I'll show you the answer. Now I'll show you the whole thing. All right. You're talking into it. All right. Any questions? Any questions about that one? All right. How do you all feel about that one? How do you all feel about that one? 5, 4, 3, 2, 1. There you go. That's good. All right, let's look at the other one here. So definitely a 3D needed here because the diene is has double bonds inside the ring. Okay. All right, so this is the 2D. Any questions? That's straight, by the way. Let's be straight. Okay. Any questions? All right, let's do the let me show the colors here. We'll do the there we go. Yeah, that's the green. That's the part that needs to be booked. That. And we'll do the bridge first. Oh, I'm sorry, forgot the double bond here. Let's do the bridge first. Okay, that's the bridge. And then we got that. So that's that double bonded, but that's the ring attached to the double bond. And then on the other side, we'll have the aldehyde groups, one up, one down. All right. There you go. Does anybody have any questions? See how you felt.
Dr. Mustard, are there methyl groups onto that point?
Right here, yeah. Yeah, let's just put them on now. Here and here. Yeah, that's good. Okay, thanks, W. All right, let's take a look at how people feel about this.
I had a question.
Yeah.
So you see where you connected the carbon to C double bond O? So that line is straight up. if I were to draw it at 45 degree, would that be wrong?
No, but it can't be flat in
Right.
relation to the other line. You can't draw it straight. You know, it can't look like a straight line with regard to the other line. But the angle doesn't really matter too much.
Okay, so as long as it's not in alignment with the green line,
Yes, you're
it's
good.
okay. Okay.
Yep. But this one I've kind of tried to draw in a line with the green line.
Right.
Very. Okay. How do you feel about this one?
Dr. Musgrave, I have a question.
Yeah, 2 seconds, Courtney. Okay, I'll end the poll here. Yeah, it looks like people are doing pretty well with it. Okay, Courtney.
How do you know one of the aldehydes is up and then the other's down?
Because, oh, hang on. Yeah, oh, you're right, actually, that they should be both up, shouldn't they? Because it's still cis.
Yeah.
Yeah,
that's
sorry
what I thought.
about that. Yeah, sorry about that. Geez, all right. You're completely correct. That was awful of me to do that. Sorry about that.
I just wanted to make sure. So
No, I appreciate you asking. I appreciate you asking. Yeah. All right. Does anybody have any questions? Any other questions? All right. We'll leave it there, and I'll catch you all on Thursday. Thank you.
Thank you.
Thank you.
Anybody wants to hang around?
Thank you.
Emily, did you need something from me? Okay.